In the past, I provided parents with their child's grades on tests and quizzes. However, the problem with just posting this information is that scores exist without context. Knowing your child made a 90 might excite you, but if everyone else in the class made a 100, your feeling towards that 90 changes. Similarly, if you found your child's 90 was the highest in the class and everyone else was in the 70s, you might feel differently about that 90 even if your child tended to get a 95. To try and give some context, I started posting the class averages on the wall for students to see after each test or quiz. I did give some context that helped students better understand their scores in terms of what was generally normal for all students. And I was ready to roll that out to parents, but the problem with averages is that extreme scores move the averages greatly. So as you can see, if we have 26 students here, and all but one make an 80, and then this one makes a 0, that class average is around 77-ish, right? This is an overly simplified example, but you can see how most of these problems with averages could make students feel that they're doing either much better than most of other students. However, their grade could actually be the second lowest in the class if you had a situation like this, where maybe most people made an 80 and then they had, maybe a 75 or a lower grade, and that low 0 pulls that average way down so that really this person's 5 points below pretty much the entire class. But they feel like they're only 1 point behind the average. Or maybe they have a 77, right, which isn't that much behind everybody. Again, this is kind of an overly simplified example, but you can kind of see how that 77 is above the average, but is in fact the second lowest grade in the class. So to try and alleviate some of this, I was looking for a measure that would account for extreme scores. If you got some, if you had generally a lower scoring test, but you had a native speaker who scored very high and got 100. If you had maybe a student who scored very low because they weren't trying, and then they pull that average down, making everyone feel like they're doing better than maybe they actually are, just because that average has been dramatically lowered by one kind of oddball score. And that's when I found the concept of z-scores. The calculation of the z-scores are fairly complex, but basically it's taking whatever the spread of the scores is. You can kind of see a spread over here. I'm going to switch this out to maybe a more logical example, maybe more typical of kind of the distribution of what students might look like. So you can see the spread over here. And a z-score, in simple terms, takes that spread, and that spread could be very wide, it could be very narrow, depending on how closely people are clustered around that average. Do you have extreme scores? Do you have lower scores? But the z-score basically spreads or contracts that kind of data pinpoint spread, so it either gets bigger or smaller to make it a consistent distance, right? There's not a number of that, but you can imagine it like, let's say we compress all of these points so that they're only within a 20-point spread. And if you had a test in which everybody was very tightly clustered around an 80 and they were within 3 points of an 80, the z-score would take that and stretch it out so that all the points hit that 20-point mark. So you're able to compare, right? No matter how clustered they are or how spread out and kind of just pinpointed, dotted they are, that z-score gives you a consistent measure to find within the cluster of all the data points, where does your child fall? Right? It's a good analogy. Is it's similar to a percentile rank, in that people may score typically fairly high, but what percentage of students were below your child? It kind of gives you that, regardless of how this is distributed, a consistent measure. Now, keep in mind, of course, a few things about z-scores. Z-scores that are above average are always positive by definition. Right? Scores below the class average are always negative by definition. No matter how big that number is or how small it is, right? It's above or below the average. The bigger the number it is, in either direction, more positive or more negative, then that shows that the child was at one of these more extreme ends of the pack. So these people up here at the very top are going to have very high z-scores, and these people at the bottom are going to have larger numbers, but in the negative column, so more like -2 z-scores, because they're at the extremes of the pack. They're the farthest away from where everyone else is distributed. And of course, as you get closer to the average, that number gets smaller and smaller, approaching 0. So somebody who's right at the average may have a z-score of 0.01 or 0.02. Now, to illustrate another aspect of z-scores, notice that in this example here, we have Courtney, and Courtney is almost 19 points below the average. The z-score is negative 1.09. But if I were to come in and switch out this data, and in this data, I've intentionally made it so that everybody is within 10 points of the average. Right? The average is about 70. Everyone has either a 60 or a 70 or something in those, in the 60s or in the 70s. So it's much more tightly kind of clustered together, as you can see over here. Right? It's very more compact and a little bit tighter. So if we look, remember Courtney was 19 points away from the average with a z-score of negative 1.09. Well, in this case, we have Maria, who is 6.5 points away from the average, right? Very close to the average. It's only rounding 7 points from the average. But the z-score is about the same as what Courtney was at 19 points away from the average. Right? The reason for this is because this data is much more clustered. A difference of 6.5 points is equivalent in terms of percentile and kind of change within this. It's about equivalent to a 19-point drop in the previous example, which was spread out over almost the entire range of possible scores. So this kind of gives you, again, kind of an example of what z-scores look like, what they mean, and it also points out the need to really look at all three numbers I include on these emails as well. It's important to look at the actual score, the average as a whole. That kind of tells you a little something about this, even though it can be skewed in some ways. Oftentimes the average does give you a pretty good look at how are people doing in general. And then it also is important to look at that z-score so you can see how your child compared to others. But you need to look at all three, because as you can kind of see here, whenever you have somebody who's very tightly clustered, a smaller amount, such as 6 points rather than 19, could actually result in a fairly extreme z-score. I had an example earlier with a test in which a lot of the kids, actually all the kids, did very well. Pretty much every kid was in the 90s. And so I had some parents who were very scared because their student had a z-score of negative 0.45, and they're thinking, well, that's fairly low, percentile rank. Obviously, that's a well off the average. It does represent being the bottom of the pack. I think that student may have been the second or third lowest in the class. The student also made a 93, right? Because everybody was very tightly clustered around that 95, which was the class average. Person with a 93 had a very high z-score, that they were well below the average of the class and well below most of their classmates. But in fact, 93 is not that bad. Right, so it is important to look at all three to kind of get a good example. The z-score is not intended to be taken by itself any more than the average is, and really any more than that one score is, because I want to try and give you some context so you can understand how is your child doing. Are they progressing? Are they able to, are they kind of doing about as well as their classmates? Are they kind of beating the average? How are they able to do within this realm? And hopefully we can encourage everybody to be moving up.